So in this video, we're going to talk about how to use linear functions to model data in Desmos. So when you plot data points on a grid, the resulting graph is called a scatter plot. By looking at the pattern of the data points in a scatter plot, you can draw in a trend line that will represent the pattern in the data. Trend lines are considered to be a good fit or a bad fit depending on how well they represent the data in the graph. So here it says the scatter plot to the right shows the lengths in inches and weights in pounds of a random sample of newborn infants. Draw a linear model for this scatter plot. So when you draw a linear model, we're just drawing in a line that kind of approximately tells you the trend in the data. Okay, it doesn't have to pass through every single point, but it's just kind of giving you an idea of what's going on. Here's a little bit better image of the linear model. You can do what we did, which is called finding a line of best fit, which is a regression line, given a set of data points. You can do regression lines or find a line of best fit using your calculator. So in this video, we're going to talk about how to do this on Desmos. In the previous video I posted, we talked about how to do it on the TI calculator. So here are your Desmos instructions. Okay, so whenever you want to do linear regressions, remember we need to start off by creating a table of values. Okay, so if you're given a graph, make sure you put your information into a table. And then what you're going to do is you're going to click this plus sign in the upper left-hand corner, and you're going to choose the option that says table. And then what you're going to do is you're going to enter the values that are given in the chart into the table. So I'm going to enter in X1, I'm going to enter 2, 4, and you can see Desmos sometimes tries to predict the next value. So you just keep typing, okay? Don't let that confuse you. Just keep typing whatever you have is given in the problem. Okay, so in Y, I'm going to do 10.7, 10.5, 15.75, and 22.75. So once you have these values entered in, you're going to tell Desmos to approximate a linear function. So you're going to type y1 is approximately mx1 plus b, and then it's going to figure out the line for you. So what it does here under parameters, you can see is it tells you the value of m and it tells you the value of b. So you can plug these values back into y equals mx plus b to get the equation of the line, which is y equals 1.75x plus 3.5. So using the equation that you just wrote, you can predict a future value like we did in the previous problem, right? So for example, if you want to find the value when x equals 15, you just say y equals 1.75 times 15 plus 3.5. Okay, so you can just do that on your calculator. We are going to do, let's see, 1.75 times 15 plus 3.5. And when you hit enter, that tells you 29.75. Okay, so that's how you can evaluate a function at a specific value once you have your regression equation. Okay, so let's try this example. It says Angelo surveyed 10 randomly selected students to find out how many pages were in the last fiction book they read and how many days they took to finish it. The results of his survey are shown below. So we're going to find a line of best fit for this data. So what we're going to do, and what's helpful in Desmos, I think, whenever you're starting a new problem is just to exit out of everything you already have, okay? Because if you continue typing, what it does is it renumbers your variables, and then things can get a little messy. So since pages is our input, we're going to call pages our x value, and we're going to call the number of days our y value. So what we're going to do is we're going to click the plus sign and click table, and I'm going to pause the video and let you go ahead and enter these values into your table. Okay, so now you can see here I have all these values entered into my table, so I'm going to tell it to approximate a linear function. So I'm going to say y1 is approximately mx1 plus b, and that is going to give me the information that I need to write my equation. So my equation is going to be y equals 0.019x plus b, which is 1.94. Okay, so it says if you use that line to predict the number of days it would take a student to reach a 350-page book, how accurate do you think it would be? Okay, so what we can do is we can plug in here. So we have y equals 0.019 times 350, right? Because that's our value of x, plus 1.94. So if we just do this on our calculator, we have 0.019 times 350, and then plus 1.94. And then when you hit enter, it tells you 8.59. Okay, so about 8.5 days to read a 350-page book. So it's asking us how accurate the prediction is. To figure out the accuracy, you're going to look at the R value, okay? Notice the R value is about 0.4. So since R is approximately 0.4, that is not a good prediction, okay? Because we want our R value to be as close to 1 as possible. So an R value of about 0.4, that is not a great correlation. So that means our prediction is probably not going to be pretty accurate. Okay, so if the R was 1 or like 0.9 or something, that would be a good prediction. Okay, so now I'm going to pause the video and let you go ahead and try this example on your own. Okay, so I've gone ahead and entered this value into my table. The time played is going to be my value of x. The number of points is going to be the value of y. So what we're going to do now is we're going to tell Desmos to approximate a linear function. So y1 is approximately mx1 plus b. And then if we scroll down, we can see the values of m and b. So this equation is going to be y equals 0.88x minus 10.5. So now it wants us to predict her score if she played for 20 minutes. So we have y equals 0.88 times 20 minus 10.5. And so that equals, if you just do that on your calculator, we do 0.88 times 20 minus 10.5. And that is about 7.1. So we say she scores about 7 points if she plays for 20 minutes. And let's see. It doesn't ask us how good fit this is, but just if you want to, you see here the R value is 0.98. That's very close to 1, so this is going to be a pretty good prediction. Okay, so using your calculator, you can model data from linear regressions, and then you can use these equations to predict future values.